Hello and welcome. This is Microsoft Flight Simulator and this is the Phoenix Airbus A320. And we are back in the squirrel, and squirrel means electrics. Don't ask me why, but that's just the way it is. So, before we get started, if you haven't watched the previous video where we discuss all the electrics in the A320, then I would really encourage you to do so now, because we will follow on from that video, and essentially I will assume that you have just watched that video and that you have remembered how all the circuits work. So today we are going through the emergency Elec configuration. Very complex, but also very useful to us as pilots. Alright, let's get started. So before we get started, let's go back to our amazing graphics here. So you may remember this was where we finished, sort of. This was one slide before we started talking about the inverter. In any case, I would like to show you now what the emergency Elec configuration looks like. And this is what we have. So in the emergency Elec configuration, you deploy the RAT, which will run the emergency generator, and that will only supply the AC essential bus, the DC essential bus via the essential rectifier. And that's basically it. So you have a very basic setup. You are losing 75% of all electrics on board. Why would we do this? Well, let's discuss it and how to fly the aircraft in this configuration. It's quite complex, but also there is a nice little feature that Airbus has given us for the landing. Okay, so we have taken off and we are flying out here over the ocean, away from any populated areas. We're gonna do all of this out over the water. As the aircraft is climbing out, let me explain to you why we do this and under what circumstances we would actually initiate the emergency Elec configuration. Right, so in the last video we discussed all the electrics on the Airbus A320. And if you remember, there was a lot of that. This is an aircraft that is full of electric circuits and features and buses and all sorts of things. So one of the biggest threats for us as pilots is of course an electrical fire. And unfortunately, when it comes to fires in aviation, electrical fires are right up there amongst the most common causes of a fire on board. The tricky bit with electrical fires is that they usually happen behind some panels, so they're not easily accessible. Also, as long as the electrics are running, they get everything they need to keep going, and of course they are usually occurring at very high temperatures, and even though aircraft are made of fire retardant or resistant materials, they have the possibility and capabilities to set other parts of the aircraft on fire. The smoke of an electrical fire is unfortunately very hazardous. It can be lethal even in small doses to us humans. So whenever we detect smoke in the cockpit, one of the first things we do is put on the oxygen masks, and then we have a checklist that we follow that will try and help us to isolate the fire and switch off that particular system of the aircraft. So we follow that checklist first to see if we can figure out where the fire is coming from. It's a very simple process in terms of, well, if you take a step back and look at it, the first thing you do is protect yourself and the aircraft. So you put the oxygen masks on, you set off a mayday, you may initiate an emergency descent, and then once you have a little bit of time, you start to see if you can isolate the fire, see where it's coming from, and basically isolate that part of the aircraft, because that will give you some additional time for the landing. Just to give an idea in terms of time frames here, we've had unfortunately a number of fires in the aviation industry, and the common opinion is that if you detect a fire on board, on average you have about 20 minutes before the aircraft becomes unflyable. So you need to get this thing on the ground within 20 minutes. Exception, of course, if you can isolate the fire and extinguish it or keep it at bay, that will obviously give you more time. So as you can see, a very dramatic event, something I hope I will never ever have to experience, but we train for it on a regular basis. We are given fires in flight and the instructor will start the stopwatch. They want us to do all the procedures, they want us to follow all the checklists, but they also want us to get on the ground within the 20-minute time frame. So very stressful, very high workload scenario, but like I said, we train for it, we go through it. So what has any of that to do with the emergency Elec configuration? Well, essentially what Airbus has done, it has given us this tool for when we are simply not able to figure out where the fire is. Like I said, when we looked at the graph, you basically switch off almost the entire aircraft with the exception of a few very essential things. Now it makes the workload in the cockpit very, very high. There is no autopilot, no auto thrust, you have no flight directors, it's basic raw data flying, and of course everything like communication and tuning in stuff is, you know, we're not used to any of this on the Airbus. You are also going into alternate law, which means you're losing all your protections. So there's a long list of things that you are using. In fact, it is so long that Airbus has given us a list of things that are actually working, which is much shorter, I'm afraid. So this is a tool we have. And the amazing thing about this tool is that it is literally done by pressing 3 buttons. Now that in itself may not sound amazing, but you can also revert it by pressing the same buttons again, and you have all the electrics back. So the idea with that is that you go into the emergency Elec configuration, you shut down everything that is not seen as absolutely essential on the aircraft. You get the aircraft to an airport, and about 3 minutes before landing, or 2,000 feet, something around that, you actually go back into normal mode, perform a normal landing, and then you switch off the aircraft when you're on the ground. So even if you go back into normal mode and that would relight the fire, it would only have another 2-3 minutes to burn, and then you're ready on the ground. So that's the theory behind it all, and this is also how we practice it. I think it's a clever tool because it really gives you some time. Yes, the workload in the cockpit is high. Yes, on the Airbus we're really not used to flying like this, tuning in frequencies. At the end we actually lose the trim, which for us is it's a huge deal. Some Boeing pilots may be laughing now, but we don't trim on the bus ever. So we're just not used to this, and my entire career was on Airbus. I haven't touched the trim, I don't know, for thousands and thousands of hours. So yes, the workload is high, but the chances are that you actually get rid of the fire, and that will buy you time. And if you get that time, if you see that the smoke actually dissipates, that means you have a bit more leeway. Of course, you still want to get onto the ground as fast as you can, but it may give you the chance to slow down a little bit, make sure everything is done properly, and then just put all the electrics on just before the landing to make sure you have just a normal standard approach and landing. And once on the ground, of course, we shut everything off, and then we need to decide whether we evacuate the aircraft or that everyone can stay on board. So that's the theory behind it, and I would like to show you now how this all works. Okay, so we are on the flight deck. As you can see, we are currently flying at flight level 250. We are on a selected speed, and if we come down here, the Elec page shows us that everything is in normal configuration, just like we discussed last time, with both generators feeding everything, batteries fully charged. So everything is good, we're just cruising along, and now unfortunately we detect some smoke coming from somewhere within the cockpit. By the way, electrical fires don't necessarily need to be in the cockpit, they can also happen in the cabin. So this could also be that the cabin crew calls you and says, there is some smoke in the cabin. So we then get our EFB and we open the so-called smoke fumes avionic smoke checklist. And this checklist starts with one big word, well, it's two words in big bold red letters, and they say land as soon as possible. So keep yourself safe, keep the aircraft safe. If the smoke becomes too much, put on the oxygen masks, which are of course here. Again, we discussed this in another video, how they work. And then we set off a mayday and turn immediately to the nearest airport. It is time critical, this event, and you need to treat it as such. Then we go through the checklist, which asks us to switch certain things off. Wait a few seconds to see if it makes an improvement to the smoke. If not, we switch them back on, switch other things off. It's essentially a way for us to see if we can isolate the fire. Now if that works, great. If we switch something off and the smoke stops, then we have essentially done our job. We have at least stopped the fire from spreading any further, hopefully, and we can just concentrate on flying the aircraft. But if all of that fails and the smoke just keeps coming, then the checklist essentially says if any of this is not successful and if the smoke becomes the greatest threat, then please consider the Elec emergency configuration. And if this is the case, you click on that sentence and that will take you directly to the procedure. So let's go through that now. Okay, so for the emergency Elec configuration, you need those two panels. The Elec panel, which I guess makes sense, but you also need this one here, the emergency Elec power panel. This panel only exists for the purpose of electrical emergencies. We never use this in normal flight. So let's start the checklist then. It says emergency Elec generator 1 line off. So emergency Elec power, generator 1 line is here, off. Next, emergency Elec power, manual on. So you can see here it says manual on. We lift that flap because this is a very important button, and once we confirmed with our colleague, we press that button. And what this should do is it should deploy the RAT. And as we can see here, the RAT has been deployed and is spinning and is now providing power to the emergency generator. So if we look at what the aircraft is showing us now, we're obviously getting a warning up here on the ECAM, but we have just produced this warning, so we can ignore it for now. And if we look at the Elec page, you can see the emergency generator is now running and is providing the AC bus because it's producing AC, and via the essential rectifier, the DC essential bus. So all we have to do now is isolate this middle part of the system, so shut down everything around it so that only the emergency generator is providing power to the essential buses and everything else is shut off. Okay, so the next point in the checklist says when emergency generator available. Well, we've just checked that on the Elec page. We could see that the RAT is extended. So then it says APU generator off, and finally generator 2 off. Okay, so with that off, the aircraft has a bit of a hissy fit because it thinks we've just had a massive power failure, which we've had, but this has been done on purpose. So the aircraft will now give you a checklist, and this checklist is actually quite important because it will give you certain things. Like here it says the minimum RAT speed is 140 knots. That's very important. Do not go below that speed, otherwise you will lose all power. But of course it will also ask you to switch on the generators. This is something you need to skip because we switched them on because we had a fire. So you need to go through that checklist, but be careful. Now you can see we've lost half of the screens. To get these screens down here back, you need to press the button and keep it pressed. So if you want to see what's going on the Elec page, we press it here, And actually, if you can see now, we have exactly what we wanted. We have the emergency generator running the 2 essential buses, and the rest is isolated. So with this configuration, we are in, well, according to Airbus at least, the safest configuration in terms of a fire on board. So we would now fly this aircraft to the nearest airport. Obviously we set off a mayday, we will have done a NITS briefing with the crew and informed the passengers, etc, etc. The workload is very high. Flying wise, well, the captain is obviously pilot flying because there's nothing on the FO side, but believe me, even the FO has his hands full in a scenario like this, because the captain needs to hand fly the aircraft, so he has very little capacity to support his colleague. Very important, you are now in alternate law. You can see this with these 2 X's here. Alternate law means that you still have to fly by wire, so you can see I just put the nose where I want it to be, and the fly-by-wire system keeps it there, but obviously we have lost a lot of our protections. Also very important, if you have the emergency Elec config on, is that the fuel pumps are no longer working. So the fuel is now running into the engines simply by gravity. So whatever you do, do not induce any negative G's, because that could stop the fuel flow into the engines, and that could cause another big problem. So be very careful with how you handle the aircraft. Be smooth, be gentle, and be aware that there are no protections available, so you can now overstress the aircraft without any interference from the aircraft system. If you decide to land this aircraft in this configuration for whatever reason, you do not want to go back to a fully powered up aircraft, then once you put the gear down, you will actually go into direct law. And direct law, believe me, I mean, I only know it from the sim, but it's really not nice. The aircraft it feels very odd, it's very direct. Essentially every input you give is given unfiltered to the flight controls. This is not how we usually fly the Airbus. It's very unusual, it feels unnatural, and of course you have no longer auto trim, so you need to use this wheel here to trim the aircraft. It's it's not great. It's flyable, absolutely, and again we train it. So the way we tend to do it, at least at my company, is very simple. You fly down the ILS and you slow down all the way to the final approach speed, which would be 140 knots to keep the rat running. And only once you're at 140 knots and nicely established, then you put the gear down. The aircraft doesn't need any trim. You just put the flaps down, the remaining ones, and land the aircraft. So that's how we do it to minimize the workload on board the aircraft. I don't know if other companies have different procedures, but generally the idea is that you actually switch everything back on just before landing. So you would now be working through these checklists. You have additional checklists, but we have them on the EFB. A whole long list of things you need to consider in terms of landing distance calculations, etc, etc. You no longer have auto brakes, so you need to produce manual braking. Again, we've discussed this with the maximum of 1000 psi. So you would have a lot of work on your hands to prepare the landing, making sure the landing runway is long enough, the weather is good enough, etc, etc. And then just before you come into land, you obviously want your aircraft back. And to do that, all you have to do is go to generator 2, switch it back on, go to the emergency Elec generator 1 line and switch it back on. And that is it. You have your Airbus back. Not everything exactly. As you can see on the FO side, things are still missing, but you can now fly the aircraft nicely down an ILS and land with the help of the aircraft itself and all the systems that you need. You have all the screens back as well. So this is the idea of the emergency Elec configuration. I'm not going to go through all the checks because it's a long list, and a lot of it, let's be honest, is really not relevant to you in the sim. But some of you wanted to talk about it. I think some of you were just curious what it is, how it works, and when and how we would use it. And I really hope I was able to answer that question with this video, going through the procedure and showing you exactly what happens in the cockpit. And that is that. We have discussed the electrics, we have discussed the emergency Elec configuration. Try to say that 10 times in a row. I think we're done with electrics now, unless there's something else you want to talk about. I think we've seen everything there is to see. I know some of you also wanted to talk about hydraulics and other systems, so maybe we'll carry on this series and do the same again with hydraulics, followed by hydraulics failure, and then maybe look at the packs and bleed systems and go through that as well, again with some failures that are typical for sim checks and sim check rides. And then I think, to be honest with you, we are slowly but surely reaching the end of this series. I've worked my way through your questions. There's a few more left, but I feel like this series has covered a huge chunk of what can be done in the Phoenix A320. Anyway, if there's anything else you want me to talk about, anything else you want to discuss, please leave me a comment. I will certainly look at it and see if the Phoenix can be used to show it to you. And that's it. So let's wrap up electrics. And with our squirrel flying with the rad still extended, of course you can't retract it in the air, it needs to be done by maintenance. We have come to the end of this video. I hope you enjoyed it, I hope you found it useful, and I look forward to seeing you in the next one. Until then, all the best. Bye bye.